I've made several videos about the Riemann hypothesis, and regardless of the video, there's always someone that will come to the comments and incredibly exaggerate the consequences of a proof of the Riemann hypothesis to a level that is just like bizarre. Like these comments, like the Riemann hypothesis, a proof of the Riemann hypothesis would transform the entire field of cybersecurity, improve telecoms with error correction, transform finance. That's all nonsense. The Riemann hypothesis is really important for historical reasons and also for very technical reasons in mathematics, and many other results are actually depending on the Riemann hypothesis, but they're always sort of like improvements on results we already know. And well, you can assume the Riemann hypothesis, and since we think it's true, nothing should go wrong either. But in any case, what's the Riemann hypothesis? The Riemann hypothesis is a conjecture about the zeros of a complex function called the Riemann zeta function. And the Riemann zeta function has, we know that it has zeros at negative even integers, and we know that the rest of the zeros, if there are any, are in this band. In the band, like this is the complex plane, and they are between here and here. So there are zeros that the real part is between 0 and 1. And we know there are a lot of zeros whose real part is a half. And the conjecture by Riemann is that all the non-trivial zeros, or not those, any other zeros of the Riemann hypothesis have real part equal to 1/2. So they are all in this line, in this dotted line over here. So what are the consequences of the Riemann hypothesis? The Riemann zeta function is closely related to the distribution of prime numbers, so knowing the Riemann hypothesis would give us better, finer information on the distribution of primes, but it wouldn't tell us where exactly the primes are in the number line. It would just give us better bounds on how many primes are there up to a number x. So for example, here pi of x is the prime counting function. How many primes are there up to x? We know from the prime number theorem that the logarithmic integral is a good approximation, and the Riemann hypothesis would just give us a better error bound for that approximation. That's all. Or, for example, the Riemann hypothesis would tell us better estimates on what is the largest gap between two primes. But it wouldn't tell us, given a prime, what is the next prime. So, as far as I know, the Riemann hypothesis, you can use it now if you want for applications, and knowing the proof of the Riemann hypothesis would not improve any of the applications of number theory to real life.